For the next problem, let's find the mean if the standard deviation equals 2.5, the raw score or x value equals 20.75, and the percentile is the 95th percentile. So we are looking for the mean, so let's go ahead and pull up our list of formulas here. So our formula that we need is right here. So the mean is x minus z times the standard deviation. Okay, so for this problem, we need an x, we need a z, we need the standard deviation. So we already have the standard deviation here of 2.5. We have the x of 20.75. So we need the z-score. We've been given the 95th percentile, so pull up that conversion table. The 95th percentile is going to give us a z-score of 1.65. Okay, so now we have all the pieces that we need to go ahead and plug in and solve. So x is 20.75 minus the z-score of 1.65 multiplied by 2.5. So we're going to go ahead and do these first. And that is going to give us 20.75 minus 4.125. So now we need to go ahead and round this. So we are going to be left with 20.75 minus 4.13. And then that is going to give us 16.62. So our final answer is the mean is 16.62. For the next problem, we will need to find the standard deviation for a raw score of 65 at the 27th percentile if the mean is equal to 115. So, first of all, what do we need to find? What are we looking for? We are looking for the standard deviation. So if we look on our list here, here's the formula right here. So we have x minus m divided by z. Okay, so for this we need an x value, we need the mean, and we need the z-score. Okay, so the mean is already given to us at 115. The x value is already given to us right here, raw score of 65. So we need the z-score. We have the 27th percentile. So if we look at our conversion sheet here, the 27th percentile is a negative 0.61 z-score. Okay, so now we have all the pieces that we need. Let's go ahead and plug those in. So we have 65 minus our mean of 115 over the z-score of negative 0.61. So if we subtract these first, that is going to give us a negative 50 over negative 0.61, and then we divide that out. That is going to give us 81.96713. Now we need to round to this number here. So our final answer will be the standard deviation is 81.97. For the last two problems, we will be using t-values to find z-scores and raw scores. So find t if x equals 250, the mean equals 525, and the standard deviation equals 75. So if we pull out our sheet here, okay, so we need to find t. So here is our formula for t right here. So we have t equals z times 10 plus 50. Okay, so in order to find this, we need a z-score. We do not have a z-score listed anywhere in here. But we have an x of 250. We have a mean of 525, and we have a standard deviation of 75. So let's look and see if we can find a z-score formula that requires the x, the mean, and the standard deviation. Well, the first one on here requires the x, the mean, and the standard deviation. So we're actually going to use two different formulas to solve this problem. So for this one, we've got x minus m over the standard deviation. Okay, now we have everything that we need in order to solve this problem. So first off, it looks like we're going to need to find that z-score. So let's go ahead and plug the numbers in here. So our x value is 250 minus 525, which is our mean, over the standard deviation of 75. So that is going to give us a negative 275 over 75. When we calculate that out, it is going to give us a negative 3.666, and it just keeps repeating. So we need to round that to the second digit. So that's going to give us a negative 3.67, and that is going to be our z value. So we have a negative 3.67. So now we have everything we need to find t. So now, in order to find t, we just plug these numbers in here. So we have a negative 3.67 times 10 plus 50. So when we take 3.67 and multiply that by 10, we get a negative 36.7 plus 50, which is going to give us 13.3. So our final answer is t equals 13.3. For the last problem, we need to find x using t, mean, and standard deviation. So that is what we are looking for, is x. So let's go ahead and pull out our sheet here. So we need to find x. So our formula for x is right here. So we have z times the standard deviation plus the mean. Okay, and so for that we need a z-score, we need a standard deviation, and we need a mean. So we have the mean here of 60. We have a standard deviation of negative 2.5. We don't have a z-score though. So let's look on here and see if there is a formula for a z-score that we can use with the information that we have. Now this formula up here requires a raw score, a mean, and a standard deviation. So we have the mean and the standard deviation, but not the raw score. But if we look farther down, there is one that we can use the t-value for. We have the t-value here. So with our t-value of 45, we can use this formula to find our z-score. So let's go ahead and write that down. So we have t minus 50 divided by 10. Okay, now we've got everything that we're going to need. So let's go ahead and solve this one first so we can get that z-score. So the z-score is going to be t, which is 45 minus 50 divided by 10. So that's going to give us a negative 5 over 10. When we divide that out, that is going to give us a negative 0.5. Okay, so that's our z-score right there, is a negative 0.5. Now we have everything that we need. So let's go ahead and plug these into this problem here. So our x is going to be negative 0.5 times our standard deviation of negative 2.5 plus our mean of 60. So when we multiply these two first, that is going to give us a 1.25. Then we're going to add that to 60, and that is going to give us 61.25. So our final answer is x equals 61.25.